Hello everyone, I hope you're all doing beautifully well. For today's valued viewer request, we've got from Nova Brooks. Is that a real name? That's such a cool name. Hey Cap, could you do a video about the new Tempest in development for the RAF? They've added a 3-year model and some specs now. It'd be interesting to hear your take on it, and we've got a link. So I've got some boys together. Say hello, boys.
Hello, boys.
Hello.
We've got two boys. We're going to just have a discussion about it. I don't know about it, and I'm interested in learning about it. So we've got a small presentation put together here by our own Talon. Thank you for that. We've got the stream on the left there, and we've got whichever websites we want to look at about the Tempest.
So Tempest is an upcoming 6th generation fighter multi-role air.
6th gen? What does that mean? I know 5th gen is stealth.
Yeah, so 6th gen is one of those kind of nebulous marketing terms.
Well, they're all marketing terms. But yeah.
Yeah, but the interesting thing with 6th gen, which is going to be very different to what we've currently got, is a virtual cockpit. So if you sit in it without wearing the heads-up display on the helmet, you'll no displays or anything. All of the displays will be in the pilot's visor.
Okay.
And also, one of the big things that will be new on Tempest is directed energy weapons, so lasers.
Okay, that's very interesting. Sounds incredibly sci-fi, but okay. So virtual cockpit. So there is no cockpit per se. It's all in the visors, all in the guy's visor, and energy weapons rather than ballistic weapons. I'm sure we'll come on to that.
So yes, it was announced in 2018. It was a big surprise. No one knew it was coming, and they announced that you've got up in the Google tab. They turned up at a big expo with this physical model of what it would look like, and showed it off to the world and said, we're going to build this thing, and it's going to enter service supposedly in 2035. So from now on, they've got 15 years to get it done and get it into service, which is a very quick turnaround. But as we'll see later, they've come up with a ways of doing things that will hopefully let them do it a lot faster. So the primary people that are building it is BAE Systems, but it's being built by a consortium of, I think, over 400 companies, I think they said, now have some minor role in it. The big ones being BAE Systems, Rolls-Royce, who are doing the engines, Leonardo, who do a lot of the avionics and radars and that kind of stuff, and MBDA, who are a missile manufacturer, so they're doing a lot of the weapons. But they've also got people all the way down to people like Epic Games, who are helping with some of the virtual reality stuff. So it's everyone from the big defense contractors down to video game developers.
Well, that's interesting, isn't it? Because at some point, virtual battlefields, they're going to clash with real battlefields. They're going to merge with real battlefields, aren't they? The technologies. Oh,
absolutely. And so, as well as the UK, there are government-level agreements with Italy and Sweden to develop it. So Leonardo is an Italian company. MBDA is owned by a combination of BAE, Leonardo, and Airbus. So there's a strong Italian component, and also the Swedes have signed on to help. Their big component being Saab, the manufacturer of the Gripen and other such aircraft, who are not yet a formal part of the Tempest consortium, but did only yesterday announce that they're spending £50 million in the UK to develop fighter technology, which will almost certainly be Tempest, although they're not officially a part of it yet.
Roger, awesome. Okay, should we blast on with the capabilities then?
Yeah, so capabilities obviously at this stage are a little bit nebulous. Obviously it hasn't flown yet. There are full-size mock-ups, but they are just that. They're models and to show to the media rather than anything that actually flies. But headline capabilities, both it will have manned, unmanned, and optionally manned configurations.
Oh, you're gonna have to explain that to us.
So manned is just like planes are now, one pilot sitting in the seat flying the thing. Unmanned is operating like a drone, and then optionally manned would be, and can put a pilot in it, or you can fly it like a drone. And so you can have some of each in your squadron, and sometimes you send them up with pilots, sometimes you can control them from the ground.
When you say drone, do you mean like the kind of drone that gets controlled from an 18-year-old in a container somewhere?
Yeah, exactly. So one of the concepts as a potential way to use these drones in the future is to pretend in wingman pairs like we currently do, but only have the flight lead be a human pilot, and the wingman could be a drone operating alongside, which of course means you can field an awful lot more planes because you only need half as many pilots actually flying in the air at any one time.
Okay, that's that. What next?
In terms of flight characteristics, obviously it will be supersonic capable. They haven't said what kind of speed yet, but I would expect high supersonic. This will be one of the first planes with what's called a variable cycle engine. So this is something that Rolls-Royce are developing. It has been suggested in the past. It was one of the suggestions for what became the F-22. To go with the more standard engine for reliability and engineering reasons. But what a variable cycle engine is an engine that is specifically designed to optimize its characteristics in both subsonic and supersonic flight. So the way air interacts with engines when you go from subsonic to supersonic changes, and that's one of the challenges with flying supersonic. And there's different ways that you can optimize engines to be good in one or good in the other, but the idea of a variable cycle engine is it would be good in both. And they're hoping that the technology is now at a point when they can reliably build these things. And the other thing that's going to be interesting about the engine is that Rolls-Royce have developed an integral generator, motor and starter unit. So rather than the way you currently get electrical power in a fighter jet is you have a gearbox which is connected to the main shaft of the jet engine, which then spins a generator, which provides power. For the engines on the Tempest, that is all going to be built into the middle of the engine, which cuts down massively on the sort of vertical profile, so the plane will be able to be much thinner. It cuts down on power losses to friction and things like that. And also they're going to have two generator units on the different spools in the engine, so they'll be able to directly transfer power between different areas inside the jet engine and make it more efficient. And of course, power will be a big problem, especially if you're trying to run lasers off it, because you'll need huge amounts of power compared to what planes currently use.
Right, okay, so they've got rid of the generator in a way and just built it into the engine for obvious benefits. And otherwise, so you've got you've got a fan on the front and a kind of low pressure compressor set. Then we got the generators. It looks like. Then we've got a high pressure compressor set. Then we've got something I've never seen before, which is kind of a gap and then a wheel on its own. Maybe an optional compressor that it can use in certain envelope, but by the sounds of what you're saying, or it could bypass it. Maybe I can't really see how the structure works exactly. And then you've got a traditional turbine set. And then I'm guessing it's a traditional kind of tailpipe area. And then obviously the large bypass. Any idea what those, purely out of interest, this is a big pipe at the top and bottom?
So those big pipes, based on the label, there's something to do with IR signature reduction.
Oh, so you can squirt, I see, so you can squirt cold, uncompressed air over the flame.
Because one of the big things with this is going to be reducing IR signature, because whereas the 5th gen planes like the F-22, they've gone reducing their radar signatures. That's only effective up to a point when radars become so good that you can see past that stealth. And so Tempest will still be stealthy. It doesn't have so much of the stealth emphasis like the F-22 does, and they're going to start focusing more on minimizing the infrared signature and other kinds of low observable things like protecting your jet intakes from non-cooperative target recognition radar and that kind of thing.
Now I can see how it works now. There's some little gates there and there that are going to open, I think, and allow a bypass through here. Very interesting. Anyone want to talk any more about the engines or know any more about the engines, propulsion, that kind of thing? Roger. Okay, let's push on then. It's all interesting stuff. So
the next thing I've got on my list is the cockpit, as we mentioned right at the beginning. That the cockpit will be fully virtual, and not only will it be virtual, it will have gesture control capability, it will have eye tracking, so that the system's constantly paying attention to what the pilot's doing.
Oh, eye tracking. I've just
It
learned
also,
just learned that's a thing in gaming. I've been told to check it out.
Yeah. So they'll be able to get force feedback, because of course one of the big things, if you've tried using VR, if you try and use VR hand controls to interact with buttons and switches, obviously you're not actually touching anything, which can make it a little hard to use. And so they want to put force feedback into the controls.
One thing about this virtual cockpit setup, it must be incredibly cheap and easy to maintain, because I've interviewed a lot of techs, obviously, and cockpits are massively maintenance unfriendly. Gauges, systems, wires, heating, cooling, all the things in a cockpit are massively problematic. If you've just got a VR headset, which is a few £1,000, and it's all software, how easy is that?
Oh, absolutely. Because one of the things that once you've built a plane, if the pilots get in it and say, "Oh, I don't like having that dial there, I wish it was somewhere else," well, tough luck. You built the plane, you can't have a new one. But if it's software, you can just patch your cockpit display and change it. And one of the other things they want to put a virtual assistant into this cockpit, so you'll be able to have like Alexa or Siri, but the military version, helping you out with all of the stuff you're trying to do.
Absolutely, yeah, that all makes sense. So there was the steam gauge cockpit, then, if you want to call it that, or traditional cockpit. Then there was a glass cockpit, which is MFDs, which removes the steam gauges, and then there was the virtual cockpit. How interesting. Now, I wonder if, as well, if they was to be flown remotely, a drone, however you want to say it, I wonder if they get the same display. I guess they do. They get the same display on their headset.
Certainly.
One problem, but I've already thought about that, is if you're going to use a kinetic plane that needs quick reactions like this, is what you're going to do about lag. You're presumably going to beam up to a satellite, and you're always going to have a big old lag if you're going to beam up to a satellite, aren't you?
Yeah, so these things will operate. They have a system that they're calling Combat Cloud, which will allow Tempests to share their sensor data with other Tempests and with other assets in the area. And I imagine something similar will be used for drone control, that it all goes up to satellites that are dedicated to the task and then straight back down to the ground controllers. And so when you have a dedicated system like that, rather than having to go through the public internet, the latencies are going to be on the order of milliseconds. And so it's quite negligible compared to reaction times of humans.
Okay.
So sensors and electronics. So one of the big topics for this, as has been on the F-35, is sensor integration and sensor fusion. And they're going to try and take it to the next level. So rather than currently you have a radar and you might have an infrared camera or a T-pod and then an RWR and then a data link from all the other planes, and they're all kind of separate systems, and you have to operate them yourself to work out what your combined picture of the battlefield is. That will all be done at the software level, and so everything will be integrated, and the plane will put it all together for you so that the pilot has the best information all of the time. And of course, as I said, with the Combat Cloud stuff, the increasing power of computers and ability to share information between platforms will just mean that effectively what we currently have in data link gets better and better and better, so that we can be sharing as much information as possible and then implementing weapons that rely on that kind of ultra high fidelity data.
Roger. So if you go and change a data link system in traditional fighters, like say a Hornet, which is a real active, plane or whatever, you've actually got to go and you've actually got to go and change the plane. You've got to go and change all sorts of stuff, haven't you? If you're going to change, but this, you're going to the receiver, the hardware is going to be the same, isn't it? You're just going to change the software.
Yeah.
Interesting. And
the thing is that the systems that exist at the moment, the sort of cutting edge of that is Link 16. And the data transmission rate, I'm just looking on Wikipedia, max data transmission rate on Link 16 is 115 kilobytes per second. So it's really tiny amounts of data.
Which was a lot in 1980, but...
Yeah, it was a huge amount when it was designed, but it's nothing these days. And if you wanted to share like a T-pod feed in high-resolution video, that's completely impossible over something like Link 16, which hopefully it will be possible over these more advanced systems.
Is it still going to be? It must still all be radio based, though, right? I mean, even 5G and whatnot, that's all just radio based, isn't it?
Yeah, it'll be using the electromagnetic spectrum unless they've got something really super secret that they're not going to tell anyone about.
Not unlikely, but okay.
So electronic warfare capability, of course, they never tell us very much about that, but they said it's going to have built-in electronic warfare capability, and then directed energy weapons, which is the really interesting new one.
So have I got it wrong when I think about frigging lasers blowing things up, or does it mean something else, like jamming electrics with a laser or something less sexy?
It absolutely does mean lasers blowing things up.
Sweet.
So the first thing that can be done with lasers is that you can potentially intercept incoming air-to-air missiles, because if you can see it coming in, they're at it, overheat its warhead, and the thing blows up.
Oh, interesting.
So that's one of the things that they've been developing energy weapons, and of course there is one deployed energy weapon in the world at the moment on the front of the USS Ponce, which is a American ship, and they can use that. They've demonstrated using that for blowing up drones, but blowing up small boats with explosives on, and that kind of thing. And it's a case of now miniaturizing that technology down to fit it in a plane.
Here's my problem with that, and with your railgun and whatnot. One way or another, both of those need to output a lot of watts at the end of the day, a lot of power. And for the USS Ponce or whatever it's called, that's no problem. You've got a frigging nuclear generator or power station there. But this doesn't have a nuclear power station. It doesn't generate many watts with those tweedy little engines. How do you create enough kilowatts and megawatts to make a laser actually do something?
That's absolutely the challenge they're facing, and getting enough power out of the turbines, and then storing that power in capacitors that they can then release through a laser is going to be a big challenge. And obviously, as soon
as you start talking about capacitors and batteries, it's heavy. All of a sudden, it's not plane friendly.
All of this is a problem, and that's why we haven't seen. I mean, there was a laser demonstrator in the front of a 747 in years gone by, but there's never been anything in fighter-sized planes because of all of these problems, and those are the sort of engineering challenges that have got to be solved.
Those are my thing. My understanding of that kind of stuff is that there is some stuff that's not miniaturizable, and my understanding it was always going to be stuff like that was not. I'm happy to be corrected as ever, but you can miniaturize a computer because you can make the bits. You make the parts smaller, but you can't make. Batteries don't get smaller. Look, they're stuck, aren't we, with batteries?
The big change in lasers is the original lasers used a big gas discharge lamp, which was very big and very inefficient, and so that sort of stuff was never going to be able to be put on a plane. But since the invention of a thing called the laser diode, lasers can actually be very small now, and they're now subject to the rules of miniaturization of electronics rather than massive discharge lamps. And so technology with lasers is really rapidly progressing, and so I find it entirely believable to have a laser weapon in a plane like this.
Wow. I guess we've got no real information about it at the moment, like what it's going to look like. Is it going to be how it's going to be driven?
This sort of stuff is literally, they just say we will have one, and that's all the information they give out because it's all super secret.
Well, the thing about super secret, we just did an interview of 1960s F-111, and even a little bit later than that, the Raven, the Raven, EF-111B or something, and I mean, it's still decades old though, kind of 80s, early 90s, and the jamming pod still 2020 is completely classified, and we can't talk about it.
Absolutely.
Do you know what I mean? And yeah, so it's all. We're never going to hear anything about that. But anyway, that's how it goes. Okay. What's next?
So payload. It won't just be using these lasers. It is going to have your sort of traditional weapons on board. The next generation of Meteor missiles, which of course is the European better version of the AMRAAM. Yeah, it is. It's better. But the next generation of that will be on Tempest. The Spear family of air-to-surface missiles, which have network control capability. So you can fire it, and then it can be controlled by data link by someone else. Something I only found out about today is MBDA are developing a system of ground attack micro missiles for CAS.
Oh, interesting. So a guy on the ground points a laser or something?
I would assume so. It's literally, I read an MBDA press release and it said no more than that. But they're developing a ground attack micro missile system for the close air support role.
So a guy could have a tiny little laser on his gun, point it at a door or something, and a 10-pound warhead comes and drops on it or something. It would be interesting, wouldn't it?
When you're limited to your smallest practical bomb being 250 pounds,
yeah, that's the thing.
You have a minimum size of target that is practical to attack with a warhead that size, and also a maximum number of those that a plane can carry. But if you can be firing little explosives around, you can carry a lot more of them.
Okay, that's the way it's been going for a long time, obviously. Okay, I mean, is it carrying all these things? I'm guessing it's a hybrid, so it can carry stuff in the bomb bay and it can carry external stores, one would imagine.
So, interestingly, I had a look around. I've not found any mention of internal stores. They are having an internal payload bay where it'll be flexible and you'll be able to put weapons in there. You'll be able to put sensors and targeting systems in there. You'll be able to put external fuel tanks inside the payload bay. But I've not heard any mention of hanging anything under the wings because, of course, as soon as you start doing that, you lose your aerodynamic profile and you lose your low observability. So I imagine there may be facilities to do that, but it's not information about.
Roger, I'm just looking at the... what have we got here? Include direct energy, we've talked about that. Hypersonic missiles. Whatever that's used for, and swarming. Oh, you better explain this. Better explain what a hypersonic missile is and what it's used for, and what swarming technology assisted by artificial AI and machine learning means.
So, hypersonic weapons are generally Mach 5. So the place where they're currently being talked about a lot is hypersonic sea-skimming missiles for taking out ships.
Okay.
They are currently active. I think the Chinese have some, the Americans and the Russians are both developing them. And the Tempest will apparently have hypersonic weaponry. What form that will take, we don't know yet, but they said they're going to take it. And then swarming technology. This is something that the Americans have been working on for a while, but the idea is that you'll be able to drop some kind of pod out the back and it will deploy tens or hundreds of tiny drones which you can then use for all kinds of things. You can use them for reconnaissance, you can put a little explosive charge on each of them and effectively bombard an area with a flying cluster bomb, but each one can fly independently. And so the plane will, in that case, effectively becomes a mini aircraft carrier for really tiny aircraft.
That's interesting. I mean, the hypersonic anti-shipping isn't new. I mean, the Soviets, even before the 90s, I think, had hypersonic. That was always their way of getting around anti-ship defences. They had, I can't remember the old missile names now, but they were Mach 4 kind of, if you remember, missiles. I can't remember the names now, anti-ship. But anyway, carry on.
Yeah, the hypersonic technology has been around for a while. The difference with the modern stuff is that being both hypersonic and sea skimming, because of course you're then flying faster than Mach 5, a couple meter bomb, which makes it immensely harder to shoot it down.
Yeah, no, these ones are ballistic. Well, they go up to
ballistics,
300,000 feet.
So yes, we talked about directed energy weapons, and then tracking, targeting, and interception of air-to-air missiles, which of course is something we've not seen on any current generation of planes. And one of the things that's going to help enable that is something I found in the press release from Leonardo, which is they've done a lab demonstration of effectively what's a new RWR system, but compared to what currently exists, so the stuff that's on things like F-35, Leonardo's new system is 4 times as accurate and 10% of the size. So the sensor capability this thing will have is going to be absolutely insane compared to even the newest stuff that's out there at the moment.
Roger. Which is funny to think about. Think about a old 80s lantern pod. You put on a Tomcat or something, the size of it and the weight of it, and it's pretty much a mobile phone hanging out of a plane would do better than that nowadays.
Yeah. This technology's come so far.
Okay, sorry.
Using be amazing.
Roger, what's on next?
The next thing, technologies that they're using to build the thing. So they're developing a lot of new composite materials. Of course, they're not going to say what those are, but all kinds of stuff to make it lightweight, make it strong, make it low observable. And they're going to be using a lot of additive manufacturing, which is the fancy word for 3D printing. So a lot of this plane is going to be 3D printed. And so this is one of the reasons they reckon they can get it into service by 2035.
How interesting. That does make sense.
But 3D printers and armies of robots.
Roger. I'm reading about currently 1967 when Israelis stole the Mirage 5 from the French or the Swiss, and how much problem in making the thing was getting all the jigs made and all the tooling up. It takes years to get all the tooling up. Whereas if you've got 3D printers, does 3D printers just print plastic, or can it do?
No, absolutely not. You can print carbon fiber. You can print metal. You can print all kinds of things. And of course, this is all using the most cutting edge 3D printing of the stuff they haven't even told us about. But yes, they said there has already been tests done buying off-the-shelf robots that are usually put in car factories and using them to build airframes.
Why not?
And it's fast. So with next generation robots working with these 3D printers, they reckon they can build them faster and they can build them cheaper than what we currently have.
Okay, very good. I noticed the airframe style is the front is very Raptor-ish. You know what I mean? F-35-ish. It seems to be the standardized stealth model now. Intake's quite similar. I noticed it doesn't have. I noticed it's a tailless aircraft. If you know what I'm saying.
Yes. Yeah. So I think the tailless design is part of the lower observable concerns, and the same reason the Raptor has that kind of shape. And the reason we see that all of these planes coming out of the UK, out of America, out of Russia, out of China, they all start looking very much the same because the combination of wind tunnel testing for aerodynamics and radar reduction shapes all tend to converge to the same sort of shape. The same reason that most cars today tend to look fairly similar because they're all being put through the same wind tunnel testing to make them efficient.
Well, I guess,
the planes all are the same as well.
I guess when you increase the requirements of a vehicle, so you can it's not only got to go fast, but it's also got to be stealthy, but also it's got to be maneuverable, but also it's got to do this. Like in a car, it used to just look sexy, but nowadays a car has to be safe, it has to be aerodynamic, it has to be Greta friendly. Then they're all going to start conforming to a more singular shape because there's only one solution for it. For everything.
Exactly.
Very interesting. It appears to be vector thrust.
Almost certainly.
Two-way vector thrust, which will do the job. It's fine. Okay, right. What's next on the agenda?
So so we've talked about pretty much everything they've said so far about this plane, but there is another project that's coming along with it called LANCA, LANCA, the Lightweight Affordable Novel Combat Aircraft, which if you go back on the webpage, there should be a picture of somewhere. If you minimize the window with the plane in it and then scroll up, there is a button that says LANCA. All this information, of course, if people didn't see it at the beginning, it's from the RAF.
Okay, looks like a mini plane.
Yeah, it is. So LANCA is basically a support drone system that they're developing to go along with Tempest and with the F-35 because those will be the aircraft most likely operating by the time these things are around. The idea being that these will be drones that can provide increased capability and also safety for operating these planes, of course, because if you can fly something that's got just as good sensors but is smaller, doesn't have a human in it, and is cheaper, you can take more risks with that. And if one gets shot down, not a big deal. Whereas if you lose your manned plane, it is a big deal. So they're hoping that by developing this alongside, they'll be able to integrate it and operate them alongside Tempest.
So I get the feeling you'd have kind of 5 of these for every Tempest or something like that.
Quite possibly, yeah.
Right. Okay.
There's less information about LANCA out there at the moment.
Does it say if it's going to be a weapon delivery system or if it's just... Does it say if this is a weapons delivery system or if it's just going to be for recce or...
It hasn't said. Like, literally all of the information about this is this webpage.
Yeah.
I imagine it probably will be weapons capable. But it will definitely be sensors capable. And so you'll be able to do a lot more, because there's the key part of winning the air war is winning the information war more than anything else. The weapons are all so good and the planes are all so capable that the lost is in information rather than anything else.
I haven't read anything about costings.
No, I haven't either.
Bearing in mind this is paid by you or me, you'd usually want to see something about costings.
Yeah, the first round of funding from the MOD gave them £2 billion for the development. That was announced back in, I think, 2018 and runs up until, I think, next year. When there'll be, of course, a round of... Basically, they have to show the government what they've done and convince them that it's worth their money still. And then I think I read somewhere that there's a decision to be made in 2025, which is effectively the final go, no-go on building the thing. So hopefully we will start seeing more demonstrators and more information coming out at some point to give us more sort of knowledge about this.
Okay.
But it's a big project. They said that currently I think there's 1,800 people working on it. That's going up to 2,500 next year. So it's a big deal, and it almost certainly is coming. And hopefully 15 years' time we'll see these in active service.
Yeah. Okay. It's good that it's still got the pilot. At least, we're not getting rid of pilots fully yet.
No.
I'll start losing interest a bit when the pilots have gone, to be honest. All right. Very good preparation for Talon. Any guys here or in the stream got any questions for him or us or whatever?
How do you think, capability-wise, they'll handle, if they do go to drone pilots, obviously, situational awareness and things like that, dogfighting possibly with a manned aircraft? Now, obviously, it'll be able to pull more Gs because there's not a human inside the aircraft, and that's obviously the limit in regards to G-force. Obviously, the airframe will have a limitation, but it'll be higher than the human compared to the situational awareness and basic surroundings.
Well, I think with the amount of sensor technology that they're hoping to put into one of these, I think being able to wear the helmet back at your drone base somewhere will give you almost as much situational awareness as the pilot sitting in the cockpit. Because when you've got that much sensor data coming from all around the aircraft, looking out the window with your eyes starts to become a little less relevant. And whilst with the stuff we have in DCS, the sort of the golden age of fighter pilots, looking out of the window was the best thing to do. I think that's going to become less and less important. And so these things will almost certainly, especially as you say, with the increased ability to pull Gs when you don't have to worry about a human blacking out, will make them really quite fearsome dogfighters.
Also probably lose a ton of life support equipment. Think of all the things that have to be there to keep that pilot alive.
Yeah, you have to put so much equipment in there just for making sure the pilot stays alive. Obviously, you don't need an ejector seat. Those things weigh an absolute ton. So they'll be light and agile once you take all of that stuff out.
Roger. By the launch date of 2035, aren't they concerned about being behind whatever the new technology is at the time? That's a fair point, but I mean, it's a bit like kind of waiting. Like I'm trying to buy a new PC at the moment, and everyone keeps saying, "No, wait until the next thing comes out." It's like, well, when do you stop waiting? Because it's going to keep coming out all the time. Every few months, a new one's going to come out. You've got to, at some point, just build the best thing you can, right?
That always the thing for sort of military hardware. That when you spend time building these things, you have to at some point stop putting new stuff in as it all comes along. And so what you actually field is always going to be a little bit behind. And I know it was a big problem with the F-22, that by the time it was fielded, the computers in there were computers from the late 20th century, and they were really, really out of date compared to what the modern stuff was. But they still get the job done because these systems are built to be so specific to the job that they're doing that whilst things like the power of a general computer have increased, a computer specifically built for flying a fighter jet is not outpaced quite so quickly. And of course, even if you've got more computing power in your phone, anyone that you would be fighting with a fighter jet also has these limitations, and so their planes are also operating on the latest they had when they finalized the design. But having looked at the sort of the very little information there is out there about 6th gen planes, Tempest will probably be one of the first ones in the air. There is the USA have got their penetrating counter-air project, which has basically nothing public apart from the name. The Chinese are working on something. The Japanese announced something a while back called the I-3, but that doesn't seem to be near working yet. And there's the MiG-41 coming, which may be ready in the late 2020s.
Isn't that an old plane? As in, when I say old, I mean like 20 years or something. I heard about that.
What, the MiG-41?
Yeah, wasn't that the thing with the big intake underneath? Maybe I've got that completely wrong. Just gonna have a quick look.
I don't know. I'm just having a look.
MiG-41, yeah? Oh, no, scratch it. I've never seen that before. Wow. Gonna have to do a new video on that by the looks of it. MiG-41. Oh, you know what? It's got all that. It's kind of gone against what we said back there. It's got all the cool stealthy stuff, but somehow, like Russians do, they managed to make it look sexy. That looks proper cool. It's like MiG-21, like for the 21st century. Otherwise, it looks identical to everything else.
Information out there about MiG-41. Because the UK has taken an interesting approach of being very open about it, because they've used it as much as a military development program as a recruiting program to get as an engineering to sort of regenerate that that base. Because I know one of the problems that a lot of companies have, especially at the moment, is an aging workforce and an awful lot of engineers that have been doing it 30 years and are really great at their jobs, but are all getting quite close to retiring age. A project like this brings in new blood and gets that knowledge transferred to the next generation of engineers.
Roger. I wonder if that will be. I wonder if this will be out before the Tempest. I wonder if there'll be a race between Tempest and this.
Probably. Like there's very little information, but the suggestion appears to be late 2020s for the MiG-41.
Roger. Okay. Anything else before we put that to bed and then revisit it in a couple of years' time or something?
So what's interesting about this is it looks like a really modular approach to a design, whereas traditionally you would you're kind of doing a systems integration approach where you get an engine and airframe and you put all this stuff together. But this is very much how they're describing like the payload bay and the weapon system. It's almost modular, and that's also ties in well with the point about sort of the manufacturing and development process. There's going to be so many competencies that are going to be called on to develop this. I mean, it's this. I mean, just to think about this, the scope of technologies that are involved in this is huge, and the
Yeah,
scale
absolutely.
of the project.
Yeah, because you're adding new stuff, you're just cramming more stuff in the box, aren't you? And regarding modularity, modularism, whatever, I mean, one thing plane makers have understood since the very start is, well, since literally the very start of planes is, as soon as, like someone else said, as soon as it's built and it's out of date. It needs to be updated constantly. So the best way to do that is to have it fully modular, so you can just upgrade something without even, changing anything almost.
Yeah, being able to have effectively like plug and play modules
exactly.
will make it a hell of a lot easier, especially because so many of these sort of older systems like F-16, F-18, F-15, they've had issues and really long programs to integrate new weapons onto them, and it takes an awful lot of time. And the same reason like why the F-14 was retired when it was because the amount of work to integrate AMRAAM onto the F-14 was just going to be prohibitively expensive, because it wasn't designed with future upgradability in mind.
And just the bit of change from A to B took, 16 years or something. I've forgotten what it was now, but it was, decades to do a relatively simple change the engines out, change some avionics, but nothing, hugely major. It turned out to be almost impossible task to do.
Yeah. Whereas you've got here, what you actually you've got an open platform, and you just kind of build it how you want it. Even on a permission basis, it looks like you could actually do that.
Yeah, I think that's something that they're definitely taking from the way that especially modern software development has gone to making everything modular and interchangeable, which is very different from the philosophies that they're working under during the Cold War. And will hopefully bring a absolute sort of quantum leap in capability with this new generation of planes.
All right, guys, I think I'm going to wrap that up there because I've got another video to do today. But thank you for everyone for your cooperation and work you put in, and I'll see you guys later.